to welcome you all to this distinguished lecture today on Big, Smart, and Everything Data, Technology, Buildings, Cities, and the IoT, organized by the School of Planning and Architecture Vijayawada in collaboration with ASHRAE Deccan Chapter, ISHRAE Vijayawada Chapter, and IIA Andhra Pradesh Chapter. We are honored to have with us some distinguished personalities who have graciously taken the time to be here. First and foremost, I extend my warm welcome to our esteemed guest, Dr. Dury B. Crawley, Director, Bentley Systems, Incorporated, Washington, D.C., United States, who has achieved remarkable success in the field of building performance research and will be sharing our valuable insights with us today. Your presence here is truly inspiring, and we eagerly look forward to your thoughts. We are privileged to have with us Dr. R.V.S.S. Prasad, Student Chair, ASHRAE Deccan, Architect V. Venugopal, Vice Chairman, IIA AP Chapter, Dr. Sandipani Vajay, CTTC, ASHRAE Deccan, Dr. P. Anusha, Secretary, ISHRAE Vijayawada Chapter, whose presence add to the significance of this occasion. I also take this opportunity to welcome our respected director, Professor Dr. Ramesh Srikonda, whose leadership continues to guide and elevate our institution. A warm welcome as well to our Head of Department Architecture, Dr. Srinivas Daketi, for his continuous support in making events like this possible. I would also like to welcome all the deans, faculty members, and students. Now, I would like to request Professor Dr. Ramesh Srikonda, Director SPA Vijayawada, to give the opening remarks.
Good afternoon to everyone. Dear Dr. Dury Crawley, Dr. R.V.S.S. Prasad, Student Chair, ASHRAE Deccan, Architect V. Venugopal, Vice Chairman, AP AIA Chapter, Dr. Sandipani, CTTC, ASHRAE Deccan, Dr. P. Anusha, Secretary, ISHRAE, and my dear students, HODs, Deans, and all participants. It is my immense pleasure to welcome all of you to today's interesting and inspiring lecture on intriguing topic of big, smart, and everything. Covers the data, technology, buildings, and the Internet of Things, which will be delivered by highly esteemed speaker Dr. Dury Crawley, Director at Bentley Systems, US. Dr. Crawley is a globally recognized expert in the field of building performance, decarbonization, sustainable buildings, and smart cities. With over 45 years of expertise, he has been at the forefront of shaping innovative solutions that integrates the data, technology, and buildings for the betterment of our urban environment. His expertise spans across many crucial areas, including sustainability, energy efficiency, and the future of smart cities. For our students, professionals, research scholars, and fellow academicians from the field of architecture, planning, engineering, and urban development, this is a unique opportunity to learn from one of the most distinguished professionals in the industry. Dr. Crawley insights into how data and technology can revolutionize the building design and the performance will undoubtedly inspire and provide invaluable learnings to us. I would also like to extend my sincere thanks to ASHRAE Deccan Chapter and IIA AP Chapter and ISHRAE Vijayawada Chapter for this collaboration in organizing this distinguished lecture. Your support and commitment to such educational initiatives are truly appreciated. As we all know, the future of the built environment lies in the innovative solutions for sustainability and smart technologies that is a crucial and also critical that to prepare ourselves to tackle these challenges head on. Today's lecture is a step towards that direction. I am sure it will be enriching and thought-provoking experience for all of us. Once again, I thank for joining us today and I hope you will have a stimulating session. Let us give a warm welcome to Dr. Crawley with applause. Dhanyavad, Jai Hind, Jai Bharat.
Thank you so much, sir. It is now my great pleasure to invite our distinguished guest, before which I would like to give a brief introduction about him. Dr. Dury B. Crawley is a Bentley Fellow and Director of Building Performance Research with Bentley Systems Incorporated, Washington, D.C., United States, focusing on building performance, decarbonization, zero energy buildings, sustainability, and smart cities. With more than 45 years of experience in energy efficiency, renewable energy, and sustainability, Dr. Crawley has worked in engineering software development, government research, and standards development organization, as well as building design and energy consulting companies. He received his PhD in mechanical engineering from University of Strathclyde in Glasgow, Scotland on the topic of building simulation as a policy tool, and a Bachelor of Architecture from University of Tennessee, and is a registered architect. Dr. Crawley is active in ASHRAE, Director at Large on ASHRAE Board, member of Task Force on Building Decarbonization, a member of multiple standards and technical committees. He was elevated to ASHRAE Fellow in 2009. He has achieved ASHRAE BEMP certification in October 2012 and is a recipient of the ASHRAE Exceptional Service Award in 2013, Service to ASHRAE Research Award in 2012, and Distinguished Service Award 2003, and Symposium Best Paper Award in 1999 for which weather data should you use for energy simulations of commercial buildings. He is also active in International Building Performance Simulation Association. He has written more than 125 papers and articles, testified before the US Congress, lectured at more than 40 universities, and made more than 400 presentations on building energy efficiency, sustainability, and renewable energy throughout the world. As an ASHRAE Distinguished Lecturer, he has given more than 200 presentations and workshops for nearly 1,000 ASHRAE chapters throughout the world. There is indeed a wealth of achievement and contributions to share about this eminent speaker, but rather than me listing them all, it would be far more enriching to hear that directly from the person who is behind this accomplishment. So without further delay, please join me in welcoming him with a great round of applause.
Thank you. Good afternoon. I appreciate the kind invitation that the ASHRAE Deccan chapter has been able to bring. This is an amazing number of people, distinguished members of the organizations as well. Thank you. So today, it's a fun topic for me. I get to talk a lot about a lot of different things, and it's a time that I can talk about the things I've seen in my career, particularly the last 20 years or so, that have been affecting the industry and where we're moving forward. It's also a very exciting time because there's a lot happening within the building industry in general and society as well. But particularly for us, there's new technologies and systems that are really going to help us move that forward. So some of the things I've seen happening, trends, centralization of building ownership within the U.S., except for the national government. No one organization had owned even a single percentage of the building floor area, that's changed, and we've seen both in the commercial office sector and retail and other areas where we have large organizations that are interested in not only running these buildings for their businesses, but they're also interested in making them energy efficient. Climate change, top and center, not so much in my country anymore. And I don't think we're going to see much regulation. I think the rest of the world is going to have to take the load for at least the next 4 years. We've seen green sustainability, decarbonization, living buildings all really beginning to drive, at least from the architecture perspective, a lot of the decision making and moving that forward. BIM for the last 20 years has been giving us a way to easily model our buildings instead of just two-dimensional drawings or even two-dimensional electronic files. We've been able now to have something that's truly an object-based system, and that's can transform how we're dealing with it. So we're no longer constrained by the limits of our medium. Benchmarking and data. One of the real challenges, do building performance for many years, and the building performance side of things has been very difficult because we really didn't have good data on how buildings perform. There wasn't enough on that, and in many places now they are requiring building owners to provide that data and to make it public. So now we can compare how the various buildings are performing. Net zero energy buildings, communities. And I think that has been a trend that I've seen for the last 15 years, that we've seen buildings of scale now that are getting to zero. It's not just individual buildings that are small that can handle that. Resilience, given climate change and some of the problems that we've been seeing with extreme weather in places we're not used to seeing it. We just had a second round of severe floods in the U.S. just this past weekend in places that they didn't expect it. Artificial intelligence. Wow, I think we're going to have a lot of opportunity there. It's definitely a long way to being totally useful, but I think there are many things that it's already beginning to support. And then IoT and smart everything. Well, we'll see how smart some of this is, but I think there is opportunity there. We have been, for the last 50 years, working on improving the efficiency of our buildings very aggressively. This is a graph showing ASHRAE standard 90.1, which was first published 50 years ago this year. And if we start back in 1975 and go to today, the efficiency level is reduced the energy by about 75%. The green building standard, the green line there, is leading that just a bit, but it's not too far forward. Other things that have changed is just how fast technology is changing today. This recent graph just shows some things, what happens every single minute of the day. So 66,000 photos and videos are uploaded. Let's see, Snapchats, that's kind of old. 625 million TikToks watched every minute. See, 3.5 million YouTube videos. You just begin to get the sense of how large this technologies have really done. And if you start to go around the circle here, most of these weren't even around 10 or 15 years ago. So we have seen a sea change happening there. Some of the other trends we're seeing is a kind of a trend toward urbanization, where we've had large cities before, but now as we're moving today, that we're getting super large cities, that they're cities of 10, 15, 20, 30 million people. And that concentration is affecting what we need in terms of services, the infrastructure, etc. And looking back, one of the in a survey recently done, 70% of the cities said that one of the things that was really affecting them or concerned them the most: temperature increases, intense rainfall, drought, storms, floods, sea level, all various things that they are having to deal with locally. Much of the world is at significant risk with sea level rise if that happens, because a lot of the urban concentrations are along the coast globally. The other thing is international development in computer technology, and you see fixed lines kind of there at the bottom really didn't get globally, but once we have cellular, we're now getting to where almost everybody globally can get a mobile phone or has access to one anyway. Some of the problems we have, though, is that a lot of the infrastructure that we are talking about is disconnected. It's separated. So we have buildings, the energy side's not really connected, roads, the water, all the technologies there are not talking to each other, much less supporting the work of others. So one of the things that we've seen recently is the idea of a digital twin. It's not new. NASA used the idea of it 30 years ago to create essentially a model of the stations they were building, the spacecrafts, so they could model what was happening with that. But some of the things we're seeing now is infrastructure modeling, transportation, cities and urban planning being kind of one of those early days, because a digital twin is a digital representation, but it's not a static representation. It's intended to involve the data related to it, so the use of whatever the technology is or the building or the infrastructure, and then use that to evolve what's going on. So it's specifically real-world entities and the data at a specific frequency and fidelity. That intensity is really important. So here's an example of one. This is Paris. And what they did to create this was to fly a small plane over the city of Paris, back and forth, tens of thousands of photographs using a process called photogrammetry. Now, the photogrammetry can be very accurate. You could go on this model and actually measure windows and things like that. It's very accurate for that. It's not unlike some of the things that Google has been using globally to collect data from moving vehicles to be able to do that. Another example, here's something from the Weather Channel in the U.S. showing the impact of a flood at various levels, being able to show at a meter or so, cars are beginning to float, and so on as it gets. And they're trying to make the point that if you're going to see a storm surge, it's going to be catastrophic, and they're showing that specifically. Here's a little bit later model of Paris. You see Notre Dame here on the left, and this is showing how the Seine river there is flooding. And one of the wonderful things, because of the accuracy of this, you can say if we have an increase in the flow of the Seine, how much water is going to flow into the city. And so the nice thing about this as a technology is if we raise the embankments by half a meter in a few places, we might be able to prevent major flooding a lot of the year. And that's one of the key things about a digital twin. So let's talk about data and analytics. Traditional building intelligence, big data warehouses, big data, unstructured, and we've been moving more and more towards some of the advanced analytics, machine learning, using various tools, and that's really becoming powerful. We're using tools to draw insights from data that we can't see. That the data is so complex to be able to do that. Machine learning, particularly some of the new large language models, are really powerful at being able to draw information out for that. So that's, instead of having to do queries back at this traditional business intelligence scale, now we can look at the whole data set and be able to bring some structure and some knowledge from it. So, AI, a lot of hype, it will be for a while, but it's just a technique to teach the computer how to learn, reason, perceive, infer, communicate, and make decisions similar to or better than humans. I don't think we're better than yet, but they are able to, all the various tools that we've been working with are able to pull out information that you wouldn't have otherwise been able to see. There's lots of different terms. There's machine learning, neural networks, deep learning, adversarial networks, and large language models, which are actually very powerful tools. If you're trying to pull information from a huge set of text, they have ways of being able to do that. But there's not really anything odd about it or magic. It's just mathematics, statistics, and data. That's all it is using different approaches to things we've been doing for many times, but using the power of the computer. As the computers have gotten so much more powerful for that, we're getting there. So this is another reality model. This is Helsinki, the historic core. It was only 26 square kilometers, but able to use deep learning for this while they were creating that, to be able to look at and start to distinguish automatically at the machine level, not at somebody sitting there saying what each of the elements are, to look at what the roofs were, etc. And that's kind of a big step forward to be able to start identifying the various pieces there. Now, AI, as I said, lots of hype going on. They spent 20, 30 billion in 10 years ago on this, the tech giants, but now they're talking on the order of 250 to 500 billion dollars being spent on these technologies. They see such a huge potential for that, and it's saying there by 2030, just 5 years from now, that may generate economic activity of up to $13 trillion, dwarfing the size of the economies of many places in the world. So let's talk a little bit about smart tech, buildings and cities. And some various definitions I found when I was putting this together. Basically, the idea of smart city is taking data and information and the digital technology to work together to improve the quality of life. And you'll see that's kind of a recurring theme. So we can use smart cities, smart data to be able to do that. Digital intelligence to exist in urban systems, make better decisions, solve the timeless problems of cities. So it's a way to take the information we have and be able to work with it real time. And the idea, this from the UN, smart infrastructure provides a foundation for all the key themes of a smart city. So that digital infrastructure, again, is coming back together. So what's covered by that? A little bit of everything, from mobility, security, healthcare, energy, water, waste, economic development, and engagement and community. And where I've started seeing a lot of this is more the transportation and the community engagement, where cities are beginning to use this as a way to get information to and from people very quickly. Security is also important. If they're able to identify a potential threat, somebody getting robbed or somebody injured in a car accident, they have that information quickly and can respond fast. Some of the other things here, the goal overall, more efficient, responsive, and sustainable city. So this is showing lives saved in a city, lower crime rate, lower disease burden, minutes saved in transport, your daily commute, and water saved and energy saved. So there's a lot of different things that they think that smart cities are going to be able to do. So another view of some of the impacts, environmental quality, reducing greenhouse gases, energy, water use, social connectedness, and civic participation, I think is going to be one of those, again, one of the early things. Health, decreasing the burden. commute time, safety, cost of living, and employing more people. So from a couple of years ago, but this shows at least generally by region where the smart cities were emerging. This doesn't mean that's where they are now, but Asia Pacific, you're seeing Singapore, Seoul, Shanghai, Melbourne, Hong Kong. And Jaipur, Mumbai are further down on the list. But you see typical cities that you would expect that are high tech anyway, that are embracing the idea of the smart city. I think Singapore, particularly because of the scale of it, they're able to deal with it. They actually have a digital twin of the entire city and are using it not only of the buildings, but looking at infrastructure and utilities as well. So forecast benefits, again, this from Microsoft, enhancing urban mobility, smarter infrastructure, strengthening public safety, improving citizen and social care. So reconnecting people that maybe would be disconnected, maybe they don't have family around, and this would be a way to reconnect through the internet. Some of the elements of this, 21 mega cities. This is over 10 million people, and that's growing. Tokyo at this point was the largest at about 35 million, 36 million. But you see the change here on the left, where we've got very few urban people 225 years ago. By 1950, it was up to 30%. By 2040, expected that 2/3 of the world will live in one of these large cities. And there's also kind of an edge portion to that, where some of the cities have underserved population, poorer residents that are there as part of the city, but they may not be quite as visible there. And that shadow city element is definitely affecting a lot of places, particularly the biggest ones. People are coming for job opportunities. So economic influence, these big cities are 60% of the global GDP. So they are where economic drivers are happening, where people, jobs, etc. But the environmental impact can be larger. 60 to 80% of the environmental impact, the world's energy needs are in those cities as well. The other thing is real-time urban informatics is really kind of the key here, to be able to get data very quickly, to have information acted on where life safety, health, and transport are involved, but also to get that real-time feedback for citizen engagement. So here's another view, smart city in a box, sustainability, efficiency, security, and people, kind of the focus, this from another consultant. This one focusing on smart manufacturing, again from a consultant, is talking about Industry 4.0, to really starting to implement something that's engaged and integrated. Digital drives the quantum leaps to begin with, then taking the digital relationships to customers, so there's a continuous relationship there. It's not just they have a product, now they can get continuous feedback. Focusing on people and culture to drive that change is really key, and that's a big challenge for any industry, particularly manufacturing. The data and analytics, though, that's where we begin to transform, where we're beginning to use these AI tools to be able to see opportunities for efficiency, for improvement, supply chain, etc. Robust enterprise-wide data analytics, where now you're getting data about all aspects of your business. That is one of the key things that we've not had. That data is often difficult to get or to maintain, but intensely more globalization. That's kind of one of the weak parts of this, because as we saw during the pandemic, when the supply chains sort of fell apart for many of our tools, many of our products. But I was reading just yesterday there's not really a place where we can say we make one thing. When you look at, well, the example they use is the Apple Watch. The Apple iPhone. They said pieces of that are made in more than 20 countries, and there's no one country that would be there. Without that entire supply chain, that would fail. And that's true of a lot of our high-tech pieces. Cars, for example, protectionism to say only cars built here can not have tariffs on them. That's not possible because there's no such thing anymore. Car parts are made all over the world. Suppliers are in many different countries, and it's going to be very difficult for that to happen. But it does take a big investment moving forward. So here's another example. This is a idea of a structure from another consultant, but the idea looking at preventative maintenance, not only schedule, but actually able to predict when things might happen, real-time modeling, predictive quality. Now we're getting into the parts of the business where the companies are really interested. If we can keep quality high at lower cost using some of these tools, process mining, and also location-based solutions. So, Internet of Everything, IoT, means a lot of things for various people. But one of the things that's happened with 5G now hitting a lot of markets, we now are having low latency response. So we're getting almost instantaneous response. 4G is not fast enough. 3G definitely not. But with 4G, now you can respond to something you see and be sure that an action's taking. And so that real-time decision making is really key. So 5G is continuing to do that, and I think we're going to see that. It's not necessarily the high bandwidth, although that comes with that. It's that low latency, that low time you have to wait for response. So the Internet of Things has already grown. This shows just the 2020, and at that point there were 50 billion devices connected on the IoT. I'm sure today is probably over 100 billion. And it's all aspects of our life that are beginning to set there. It's a lot of money involved, too. You see 94% of companies believe IoT is going to change their marketplace. $14 trillion of combining the information gathering of IoT with the big data, the AI parts. So that, again, talking large amounts of global development there. However, one of the big problems with all of this, collecting all this data, who owns it, who should get access to it, who should be able to use and act on that data, and security really is the key. That's still one of the things that I hear concerns about it. People just don't know who should have data or who shouldn't, and how do you control that in a way that doesn't limit the use of that data, but limits the use to people who should have access to that. But being able to do that, not only our personal information, but anything else out there. So it does require cybersecurity. We've got to have ways to be able to maintain ownership and maintain restrictions about who gets access to that. So connected systems and billions of devices there, again, 50 billion, but the risks are getting even worse. We've seen hacks globally by people wanting to collect our personal information or to defraud us out of money, and has been increasing quite a bit. And there's some examples on this slide showing some of the big ones, like the largest telephone company in the U.S. was hacked, and 30 million people's information was available. So tax information, where you live, your phone, everything was all out there on the internet. That's really kind of a challenge. But it's already beginning to change. Being able to collect data to analyze use of spaces and be able to share that knowledge so we can begin to, as designers of buildings, as operators of buildings, we can begin to get more information about how our buildings were being used. Are there ways that we can improve on the next one? this is example. This is a BIM model, but it's in Singapore. This is the Microsoft headquarters for Southeast Asia. They've got floors 9 through 11, 14, I can't read. So in the BIM model, what they've been able to do is then tie into the building monitoring system and to be able to collect information so they can go space by space, see temperature trends over a particular day, see what's happening right now, and be able to look at other issues related to that. It can tie into use of the space. Are we actually effectively using the space? Occupancy here. And for one space, maybe occupied not very much. Maybe we don't need as much space as we think. And so begin to look at opportunities like that. So this is kind of first idea of connecting that IoT to the digital twin. So one of the problems with IoT in the building sector is just the cost. The sensors cost a set amount. That's not usually very much, but getting the data back to a central system or a place that it can be collected may be 10 times the cost of the sensor. And that's what's been prohibiting us from putting more data points out there, putting lots of thermostats and ways of collecting data. So wireless begins to be able to do that, but of course you need to be able to have power at those. So we've seen a number of different ways of dealing with that, with gateways, self-charging. Some of them will charge just from ambient light, PV systems. Also, other things, people counters, activity motion sensors, etc. Not unlike things we've seen already today, but it's now more capable, and because the lower cost of a single sensor, if we're not having to pay to wire it back to a central system, we'll be able to do that. But IoT is already changing construction industry. Drones, particularly example here with the two guys in the goggles in the center, being able to check out the structural integrity of our infrastructure bridges is kind of a key thing, to be able to do it with a drone instead of the traditional way, which is a guy in a harness hanging off the bridge trying to take pictures. Now we can do that and use AI techniques to be able to move forward. Asset tracking, preventive maintenance. The top right, that's Notre Dame in Paris not long after it burned. And they had created an incredibly accurate digital twin of the interiors and the exteriors just a year before that happened. So they knew exactly where everything was. I was down to less than a centimeter in measurement capability. So they were able to use that in the reconstruction that's just recently there. Here's another example. This is Philadelphia. The Pope was coming to Philly about 8-9 years ago now, and the city was worried about security. So they paid somebody to fly the city, create the 3D model that you see here, and you see the mesh that's behind that. So this is actually sitting within a BIM model. And what they were able to do, you see road signage and barriers as up the pathway that the Pope was going to be going for that particular things. It was kind of cool. It was a one-time use. But what we were able to do was take that same model and take some of the benchmark data that the city has. You see, it's not every building, but certain buildings over about 5,000 square meters were required to submit their annual electricity and water usage and costs associated with that. So what we were able to do is associate that with an address and the model itself, begin to look at it. Again, nice pictures, colors, not a lot of information to be able to work from there. But what we start having is the data behind that and being able to look at the various pieces. We can sort by an address, we can sort by a building type, we can look at energy use intensities. In this case, they've selected one, and not surprisingly, it is a hospital, which are 24/7 sort of So that's not entirely surprising for that. But that now gives us another way in. And you see there's a lot of data associated with that as well. So now we can begin to query the data and be able to look at opportunities for efficiency for water and energy. Here's another recent example. This is actually Omnibod, and what they did in this project was fly a drone over the city for about 18 months during the pandemic, unfortunately, but being able to look at the buildings and the intensity. What they were trying to do was do automatic detection of the buildings because there really wasn't good mapping of that, and being able to look at the point cloud input, and which came from the flying the drone and the models there, and then being able to now separate out what's a footprint and rectangularize, make that really the footprint for that, taking into account trees and other things as well. From that, they created energy models of each and every building in the city. They did some calibration. It's very difficult at this scale to do that, but they were then able to take that in a different view and begin to look at energy use intensity, where the opportunities might be for retrofitting buildings first. Which one should we focus on first? The largest and the most energy intensive, obviously. And the same is true in that case. There's data like I was showing you for a residential apartment. This breakout of energy use was based on, yes, the utility bills, but then from the simulations they were able to do. Another example, this is Helsinki again, and this is to show kind of the thinking they've had there. This is showing about, I think it's somewhere about a meter, maybe a meter and a half of rise, and you see the historic city would be underwater. So they have been trying to use this model and thinking about ways they could use it within the city. And they prepared this table. This is from Helsinki, from their website, and talking about the green dots are where they've already started looking at opportunities for using the digital twin, that data associated with it. Everything from smart cities, web services, education, marketing, city events, planning, transportation, building permissions, decision making, all sorts of things going on in the city. But you see how much they've not really even begun to cover. They're continuing this work, being able to do that because the city was of a scale you saw before. It was only 24 square kilometers to be able to do that. So where does that take us? This idea that IoT and these tools we're going to have and our digital twin models are going to be able to now allow us to find out information. So our building can communicate with the energy grid to understand what the carbon impact of energy use is, or renewables, what's the availability of water, transport, other things going on in the city. So a digital twin connected infrastructure kind of idea here. So the buildings connected with the energy and renewables, being able to talk and respond to each other instead of utilities just providing power, not knowing what the load's going to be. Now they can communicate and be able to use that better. I've talked a lot about various things. I like these hype curves that come out every few years. This one's a little older, but if you look at the idea is there's kind of a cool idea, an innovation trigger, and then there's this peak of inflated expectations. Well, that's where digital twins, some of the other things are at this point, or have been. Other things we're seeing that are kind of the trough of disillusionment. People are going, the hype's gone. I don't know why anybody was excited about it anymore. But augmented reality is getting it through that. I think some of the other things as well, mixed reality and some of those pieces. So watch for these because they're very interesting views of what's going on. So in summary, These 3D digital models, the digital twins specifically, going beyond just a digital static representation, but building on the data, makes it easier to understand that particular building, but also how they fit in the community and the city and how they interact with the environment as well. The sensors are going to continue to become ubiquitous in our lives. I think I read somewhere that if you're in central London at any one time, there are probably at least 5 cameras on you. And that's partly from a safety and security standpoint that they're doing that today, but you're going to be seeing that even more and more. Security, privacy, data ownership have to be solved to be able to make this work well, so that only the actors in this that know and should have access to data have access to that data. The 5G out there is beginning to make that possible in a lot more ways than have been done before. You will see even more of that powerful tool that's going to be coming forward for that. Anything that we're measuring locally probably is going to be collected more centrally. One of the key things I started out talking about was centralization of ownership, and the idea that a large retail store can know what's going on in any store. A retail store owner can know any of their stores globally, what's happening at any one point. So they can know what temperatures, what all the elements that they're looking at that are important to their business, so they can identify that quickly rather than depending on just local people. So data analytics, all the bits and pieces I've talked about, really allow us to find information that's not very visible and be able to learn from that, to expand the data pool and to allow these tools, these statistics and mathematics tools, since that's all they are, to really show us information that we can't see otherwise. Much of what you're seeing today, though, is a lot of hype. And so take it with a grain of salt. Watch what's happening in the technology. It will happen in many of these cases, just because there is just a push for getting more data, but also reducing cost, and that's going to be one way to keep doing that. So one of the things I've also learned in my career is looking at what is it we're trying to measure, what is the metric for what we're trying to do. And my career was early based on kind of these 3. How much energy are we using? What's the peak demand for that energy? And what's the capital and operating costs for that? And that was it. But what I've learned is if I don't think about some of the other things, I'm probably going to miss opportunities and may even create a problem for that. So if I'm not looking at water, indoor environmental quality, carbon emissions, there may be synergistic things that I miss for that. But it's also important to think about the business model of the organization you're working with. Retail, it's sales, so it's probably rupees per square meter is what they're thinking in terms of sales. But if it's a university or a school, what does it cost me per year to build or to operate that? And what are the opportunities for proving that? If it's a hotel, they're measured normally as revenue per occupied room. It's not per square meter or anything like that. One of the interesting ones I saw, though, in the alcohol industry, they were looking at different metrics. So they were, how much carbon am I saving per barrel of beer I'm producing or per case of wine? And so there are all sorts of metrics like that that we need to understand so we can talk to the people in the way they do the metrics. Finally, there's a data set. This is something a friend of mine has been working on for about a decade now. Climatic data that's available for use in energy simulation tools, widely available, about 17,000 locations worldwide. We had just under 5 million downloads last year, which floors both of us because we weren't really trying to get to scale with that. It's a free data set after all. But we have data now through 2023 available in that. So this is up to date. It's also in a number of different formats for other tools. But you see pretty good coverage for Asia, particularly India. There are still some places where we don't have enough data, but right now these are the stations that we can get and collect the data from. The good news is that there's a European and a US what they call reanalysis, where they take all the data from satellite ground stations and everything and put it together in a single data set, and it's gridded. The European data set now is at 9-kilometer grid, so you can get pretty close to what, if you're far away from a weather station, you can get very close to that. And the data are quite good. We do comparisons with them all the time. But so if you're interested, climate.onebuilding.org will get you there. So with that, thank you. I'd be happy to take questions. No? Where am I?
Any questions?
In the Ahmedabad energy profiling study that you showed, what was the units of the energy?
I think there was a mixture. Some of them were just showing kilowatt hours, but some of it was normalized to per square meter. If you search for I number, you can find that the data set, the site's still there, and all the findings are up. I checked that the other day. The web, I don't know what the website is specifically, but it's INUMBER. If you search for that, you can find it.
Good evening, sir. So, my question actually starts off in the country of India. So, particularly in India, where we still see a lot of passive design strategies being
Yep.
used in order to tackle problems like embodied carbon in
Mhm.
buildings or heat gain, particularly. What do you think is the rough timeline of implementation of these sort of building simulations or technologies?
I think they can be done now. I mean, passive design, a lot of the tools support that today, and being able to solve the problems without using systems and equipment as the primary way of dealing with it, but using the natural energy flows is, I think, really the first approach that should be taken.
Also, sorry, if I can just follow up
Yep.
that question with another question.
Mhm.
So, you talked a lot about digital twins
Yep.
and how we can gather a lot of data about buildings through those digital twins, or even cities for that matter.
Mhm.
So, is AI something that can be integrated with the digital twin in order to actually understand what we can do to improve the kind of problems that we see in
Yes.
buildings?
That's exactly the sort of thing AI is good for, is being able to take information from a large data set from that. As long as you're collecting data, I think that's really the key.
Thank you, sir.
Sir, in one of the slides, the EPI is 75 kilowatt hour per square foot.
Okay.
Have we reached so?
Some places 75 kilowatt hours is a good number. That's about the level in the US that we say is net zero carbon ready or net zero energy ready. So we brought the buildings. energy level down that far, and the rest of it can be made up with renewables or better grid.
So
Yeah.
maybe 20 25 years back, we have not seen much technology in building, design and all that. So we have seen a lot of changes in the 20 years, past 20 years. There smart cities and building simulations. Now whatever we were designing before were like, very sensible designs. Now we are trying to prove it through simulations and whatever. So where do you see the future of it after another 20 years? So
Where I see a lot of work now is that people are trying to take some of that initial steps of creating a design and automating it so that AI can help you do automated layouts, floor plans, different layouts that you probably would have had to do. Think about what options you want to do. Instead, it may give you a half a dozen options. And I've seen several early design tools purporting to do that. I haven't been able to check them to make sure that they are doing what they're saying, but they supposedly are doing the analysis for optimization and various elements, whether it's energy or cost or carbon or whatever. I think eventually it's going to make it a lot easier to do a lot of the rote business work of writing specifications and the other parts of that, and which have been increasingly automated, but are still, there's a lot of user interaction that has to happen with those.
Good evening, sir.
Hi.
May I have your thoughts on circular economy? Considering the amount of data that is required, and every time we are stuck with it as a concept for lack of data, but yet the concept is still all over, and we are pushing that concept. So, do you think it will work ever?
I think it's a challenge to get all the elements of the circular economy in place. It's where we need to be going because we do build a lot of buildings and tear them down for no reason, and a lot of that material just gets landfilled. It's not reused. We don't. So having that ability, I haven't seen it happening. Even in the U.S., it's still a problem because it's cheaper to put it in a landfill somewhere. So I'm hopeful, but not yet. Anybody else? Okay. Thank you very much.
Thank you for that lecture, sir. So we have circulated the feedback forms. You might have received it, so you can submit it back to the Student Council President. Now I would like to request and invite Professor Dr. Ramesh Trikonda sir and Dr. Srinivas Daketi to felicitate our eminent speaker and guest. We'll start with Dr. Dury B. Crawley sir. Please give a huge round of applause. Next, I would like to invite Dr. Sandipani Vajay, CTTC, Ashray Deccan. Next, I would like to invite Dr. RVSS Prasad, Student Chair, Ashray Deccan. Next, I would request Architect V. Venugopal, Vice Chairman, IIA AP Chapter. Now, I request guest of honors to please stay back on stage. It's time to felicitate our students who won the CSIR CBRI award at IIT Roorkee. First up, we have the students. Yes. First up, we have the students who have won the overall award for documenting vernacular architecture and the traditional houses. First up is Vishnu Kumar and D. Gunavarshi, who won second prize. I would also like to mention the name of the people who has worked effortlessly behind this, namely Kanishak, Rachita Maitre, Preet Kumar, Kush Gupta, Emmanuel, Bhavjal, Harshita, and the entire batch of third year. I would request Dr. Anusha to come on the stage. Next up, we have the next set of students who have won the award for documenting Kapileshwarpuram, award for documenting the traditional houses in the category of warm and humid climate. It is a work of third year studio award. The names are Hevti Manoj Kaila, Akshita Yadav, Tushar Mahindra Devda, and Ganesh Ravla Pati. Can we have them on stage? The people who have worked behind this are also Gautam Prasad, Kumar Harsh, Preet Kumar, Arav Kalwani, Abhishek Dasari, Bhumi, Fatima Ishka, Harsha George, Sanvi Bhardwaj, Sufail Thayil, Vivek Tushi, and Janaba. The next category award in warm and humid climate is won by the batch of second year studio, namely Kirti Janwar, Pehel Agarwal, Samruddhi Katkar, Sikhanjali Das, who had documented the traditional houses of Karaikudi, and the people who have worked behind are Tulsi, Anu, Jyotsna, Rutuja, Bhavesh, and Nandita. Can we have them on stage? Do we have anyone from second year who has worked in the documentation? So I request Dr. Lily Rose ma'am to come and receive this award. I would I would also like to mention that SPA won first prize in overall category for the CBRI awards. Now I request Dr. Srinivas Daketi to give vote of thanks.
So good evening, one and all. I would also like to mention, in the this is a recent news, just 2 days back, in the list of most influential institutions of India, IIT Mumbai and IIT Mandi emerged as top achievers, and SPA Vijayawada stood third at the national level, showing higher education institution success stories. And thanks to the entire team, and thank you, Dr. Ramesh sir, our director, IT team, all the staff, faculty, and all the people who are behind this success. So it is not a small thing. At national level, we have stood at third level. So thanks for everyone, including the students who have stood behind. And I would like to thank each and everyone for joining this exclusive talk by Dr. Crawley, and he has all the way traveled to Vijayawada just to address in SPA Vijayawada. So special thanks to Dr. Ramesh Srikonda, Director SPA Vijayawada, who has given us this opportunity and who has immediately accorded the permission to organize this. Special thanks to all the deans and Astray Deccan chapter, History Vijayawada chapter, and IAAP chapter. Dr. Anand Babu, who could not come, but thank you, Dr. RVSS Prasad, Student Chair, Astray Deccan, who has joined for this. Dr. P. Anusha, Secretary, History. Dr. Samdeepani, CTTC, Astray Deccan. Architect Venugopal, Vice Chairman, IAAP chapter. Dr. Architect Vivekananda Swami, Senior Architect from Vijayawada, and all the students. And special thanks to Dr. Fayaz and Naveen, who have played a major role in organizing this event. Thank you, one and all. And sir, I think your talk has been very informative, and would like to thank you personally and on behalf of School of Planning and Architecture and all the deans, faculty, and students, and who have made this to happen. And this is a great opportunity for us to get connected with you. And Dr. Fayez was telling, even the information for weather station, what we are trying to get is from the site which you have shown us today. Thank you once again.
The tea is the tea is there, served outside. You can have it. And make sure you submit the feedback forms.